Yes, can everybody hear me and see the screen? Hello?
Yes, sir.
Yes, sir.
Sir, there's lots of background noise.
Okay. So, in today's class, we will be speaking about the first topic called SK nearest neighbor classification, otherwise called as KNN classification. Okay. Short form is KNN, K nearest neighbor. Okay. What is the logic? Okay. The logic is very simple, students. Consider students. Raj is there. Okay. Okay. Raj is there. Now, I would like to know. Okay. Raj has been caught for a particular inquiry. Whether Raj did that or he didn't do it. Okay. Say, for example, somebody have rang the bell, rang the bell. Whether I would like to know whether Raj did really rang the bell or he did not rang the bell. Okay. So what I use is I see the friends of the Raj. Okay. If his friends are naughty friends. Okay. Say for example, Raj friend is Rajiv, which is naughty. Okay. Samuels, which is very naughty. Okay. Then John, which is also naughty. Okay. Then Kumar, he's not naughty. Okay. Then Simran, he's not naughty. So these are the five nearest people where Raj is always close to. Now, in this, okay, Raj has three close friends, Raj, okay, Samuels and John, and two people are very innocent guys, okay, Kumar and Simran. So the majority is here three, and the majority of two people who are silent. So naughty and silent. Okay, so out of five friends in total, in total, okay, three are naughty and two are silent. It means that the majority is more. It means that Raj did ring the bell. It means that Raj did ring the bell. Is it clear? Is it clear? Okay, so based on his nearest neighbors, I predict the value of Raj, whether the Raj belong to the category of naughty. Naughty means yes, he rang the bell. Yes, he could have done that, definitely. Okay, and silent is two. Okay, silent is two. Now, keeping the same concept in mind, we will proceed forward, students. Now, see here, I would like to predict a fish. Okay, I have fish, a random fish is given. I would like to predict a fish. Okay, keeping, okay, K as 3. Keeping K as 3. So when I see over here, okay, when I see over here, these are my three nearest neighbors. So two are sea bass and one is salmon fish and one is salmon fish. Two are sea bass. So what is the probability that fish is going to be in which either of these two category? So the majority is two over here and one is salmon. So this fish belongs to, if the nearest neighbor is taken as 3, if the value of k is taken as 3. So the majority, the fish belonging is the category of the classified fish is a sea bass. Okay, so tell me who your neighbors are and I will tell you who you are. Based on this particular concept, I will classify. I will classify. Okay, when k is 5, when k is 5. Okay, so now three are sea bass, one is salmon, and one is eel. One is eel. So I still belong to, my majority is sea bass. So I belong to the category called as a sea bass. I belong to the category of sea bass. It is Raj. I want to know what kind of a person it is. So who are your neighbors? Rajiv, Kiran, Samuels. Okay, John, Victor. Okay, John and Victor. So Raj, Kiran, Samuels are silent street boys and John and Victor are naughty boys. So in which category will Raj will belong? To silent boys. Raj is also silent. Raj is also silent. Okay. So this the value of k is 5. Usually students, we go for odd values. We don't go for even values. Okay, we don't go for even values, because if here also 3, here also 3, we will not be able to predict. Okay, in the KNN, we will not be able to predict which category the Raj will belong to, because it is 50-50. So it is always better to choose, and it is very good to choose K is 1, which is definitely not going to give that much prediction. Okay, K is 3, K is 5, K is 7, and it goes so on. Okay, the larger the number of neighbors, the better the accuracy it is, better the classification is. Smaller the value of the K, okay, it's okay, you can classify it, but it will not give you that much accuracy. Okay, so K is often used for efficiency but sensitive to noise, as I told you. Okay, because with the one friend, just because Raj is close to Kumar, since he is naughty, I cannot predict. Okay, but definitely, and say for example, and there are two neighbors. Okay, say for example, K is Raj. Okay, so there is only one neighbor, K is 1. Okay, can you see? K is 1, and this particular neighbor is this one, Kumar, Rajiv, Samuel, whatever it is. If I'm going to choose as K as 1, just based on Kumar is naughty or Kumar is silent, I cannot predict the value of Raj, whether he belongs to Kumar, naughty or silent. Okay, so every example in the blue shade area will be misclassified as blue, whatever it is. Okay, you can see the thing. Okay, so the algorithm goes like this: determine the K parameters. Okay, K nearest neighbors, calculate the distance between the query instance of all the training samples, sort the distance, gather the categories, and use the simple majority of the category. I will run through this particular algorithm step by step process. Okay, let us enter into how you're going to predict the who are your neighbors and how many neighbors, and then we will classify whether in what category you belong to. Okay, if to K is too small, it is a noisy point. K is too large, is not right. Let's not be bothered about this particular rule for the upcoming data. Okay, so students, okay, I have two parameters, x1 and x2, and I have some classification values: bad, bad, good, good. Okay, so x1 is asset durability. Okay, x2 feature is strength, which is measured in, this is measured in seconds and this is measured in kg square meters, whatever it is just a simple understanding. Now given this x1 and x2, I want to prove this particular chemical, whatever it is a bad chemical or a good chemical, and I have some set of values: 7, 7, 3, 1. Okay, then 7, 4, 4, 4. Okay, 7, 4, 4, 4. 7444. Now I want to predict, given a value 3 and given a value 7. Okay, given the value x1 as 3, you see x1 as 3, and given the value x2, that is the same thing I've written here, as 7, whether this chemical is a good or bad. Okay, given these two features, acid durability and its strength, whether the classification will fall into good or bad. Okay, step number 1, students. Step number 1, determine the K parameters. Okay, I am saying, for example, K is 3. K is 3. Say, for example, K is 3. Now, students, step number 2 is calculate the distance between the query instance and all the training samples. Calculate the distance between the training query instance and all the training samples. So, what is the query instance? X1 is 3 and x2 is 7. These are the query instance. Calculate the distance between all the samples distance. Okay, all the samples. Okay, and then we will proceed for the third step. Okay, now how do you calculate the distances? There are various methods. I will, okay, or mostly, okay, you also please choose Euclidean distance. Euclidean distance, and there are various distance methodology like Manhattan distance is there. There are various distance, right? Euclidean distance. So the formula for Euclidean distance is x2 minus x1 the whole squared plus y2 minus y1 the whole squared. Okay, y2 minus y1 the whole squared. Okay, so I'm going to calculate the distance between the query instance and all the training samples. So what is the query instance? Say for example, I'm just writing it down just to make you understand. 3 and 7. Okay, so this is my x1 and this is my x2. So 3 and 7 is my query instance. Okay, so 3 and 7 is my x1 and okay. Kindly please don't get the what you say what you say confused between this x1 and x2, all these things. This is a common formula. Okay, this you can have it as acid durability and strength, something like that. Okay, now students, so now this I will keep it as, for example, okay, so 3. Okay, this is my x coordinate and this is my y coordinate. Okay, so this we can have it as x2 and y2. Okay, this I can have it as x1 and y1, x1 and y1. Okay, students, when I'm talking in terms of formula. Okay, so since I have put the feature name also x1 and x2, don't get confused. Okay, fine. Okay, students, so now what apply? Okay, the distance. So x2 minus for all the parameters. So x2, that is 3. Can you see? 3 minus 7, the whole squared, plus 7 minus 7. Can you see? By 2. By 2 is 7 minus 7. Okay, I will not write it here. Okay, this is the query instance. This is just to make you understand. I have put to predict the values. Okay, predict the values. I have put it over here. Okay, so now 3 and 7. So x2 and y2 have given, x1 and y have given. So x2 minus 7, plug in the values for every single instance. For every single instance. So 3 minus 7 the whole squared plus 7 minus 7 the whole squared. The same way, 3 minus 7 the whole squared. Okay, plus 7 minus 4 the whole squared. Then 3 minus 3 the whole squared plus 7 minus 4 the whole squared. Take the square root of it. Okay, then 3 minus 1 the whole squared plus 7 minus 4 the whole squared. Take the square root of it. So when you take the square root of it, 16, 25, 9 and 13 you get. Then what I do is, then what do I do? I square root values of 16 is square root of 16 is 4, square root of 25 is 5, square root of 9 is 3, and square root of 13 is 3.605. This is the second step. So my first step is of the algorithm is determine the k parameters, calculate the distance between the query instance and the thing using equivalent distance. I have told you the formula. Now the third step is sort. Sort. So once you sort these values, okay, so the first value is what? 3. The second value is what? 3.605. The third value is what? 4. The fourth value is what? The fourth value is what? 4. 5. Can you see? So, sorry. Yes. I'm sorting. Okay. Can you see? I have given the ranking for it. Okay. Rank. So this will be my first rank. This will be my second rank. This will be my third rank. And this will be my fourth rank. So can you see? 5 is fourth rank. 5 is fourth rank. Okay, 4 is I'm just ranking, students. I'm just ranking. Okay, the lowest value will take the first rank. Okay, that's the thing. So now rank. Can you see ranking? Okay, now ranking. So 3, 4, 1, 2. Okay, students. Okay, so now I have rank. Now, what is the value of k I have chosen? What is the value of k I have chosen? 3. So out of these 3, since I have chosen k as 3, I will take the top 3 ranks. I will take the top 3 ranks. Which is the top 3 ranks? Yes. Yes. Rank 1, rank 2, and rank 3. The fourth parameter I'm not taking. I'm not considering his friend at all. Okay, I'm not considering his friend. No, because I have taken k as 3. Now, since I have taken k as 3, what is my output label? What is my output label? For all 3 labels, I am getting the classified value as yes, yes, yes. The chemical is good. The chemical is good. The chemical is good. That is yes, yes, yes means what? Yes, yes, yes. Okay, that is, can you see? Can you see? I am taking, what is it? Okay, so 3. Can you see? Where is it? 3 for this is the rank. So Can you see? Bad, bad, good, good. Okay, bad, bad, good, good. So bad, bad, good, good. But I am not taking this. This is also bad, but I have not considered this. So out of this bad, and two are goods. Okay, and two are goods. So now when k equal to 3, when k equal to 3, okay, when k equal to 3, one particular attribute is telling bad and two are saying it is good. So 3 and 7 will belong to which category? Whether it will belong to good category or bad category, which has the majority? Which has the majority, students? Which has the majority? Hello? Which has the majority?
Goods.
So then it means that it belongs to the category of good. It means that it belongs to the category of good. It means that it means that okay. You see? So this particular classification was bad. The final output was bad, bad, good, good. Okay. Since I have taken K as 3, K as 3, okay, I will take the top three ranks. This one, and this one. Okay, this will not be considered. Why? Because I have taken K as 3. So out of these three, yes means these are the neighbors. I'm just telling. Okay, don't get confused between yes and no. So these are the three neighbors I am considering. These are the three neighbors I am considering. Okay, so yes, he's the neighbor. Yes, he's the neighbor. Yes, in these three neighbors, okay, one belong to bad category and two belong to good category. So my output 3 comma 7, when it is given, it belongs to the category of good. It belongs to the category of good. It belongs to the category of good. Okay, so two bad and one good. Is it clear, students? Is it clear, everybody? How many of you understood? Quickly raise your hands. How many of you understood? Quickly raise your hands. This is all about KNN, students. Hello? Hello? I'm still waiting. Okay, students, thank you, thank you, thank you. Okay, the next concept what I will enter is weighted KNN. Okay, weighted KNN. Okay, students. In weighted KNN is a modified, it's a modified version of KNN. Okay, so this KNN has multiple issues. One of the issues is that the performance of the KNN algorithm is the choice of the hyperparameter K. That is, if we choose K as 3 and K as 5, there might be a difference, right? Because when we choose K as 3, it might give us some other output. But when I choose K as 5, it might produce some other output. If the K is too small, then the algorithm will be more sensitive to outliers. That is, if I'm going to choose K as 1, okay, just by keeping K as 1 and deciding that what type of a neighbor or what type of a guy you are, it's wrong. But if the K is too large, then the neighborhood may include too many points from the other classes. That is, if I'm going to choose K as 100, okay, as I told you in lab imbalanced data set, okay, then the majority of the class might fall into 80 might be yes and 20 might be no. Another issue is approaching is to combining the class labels. The simplest method is to take the majority vote, but this can be a problem if the nearest neighbors vary widely in distance and the closest neighbors are more reliable. That is, students, that is, say for example, students, so I would like to choose K, say for example, K as 10, K as 10. Okay, so two red dots are there. Say for example, two red dots are there. Okay, and then 7 Okay, 1 2 3 4 5 6 7. Okay, now if I'm going to give k as 10, can you see students, the nearest neighbor is 3, which is having more impact on this. Okay, and there are 7 other neighbors, they are very far from this particular guy. But if I'm going to go for KNN, then I have to choose this one. Yes, I have to choose this one because the majority is 7. Here 3. Okay, but here these 3 are very near to it and these 7 are very far from it. The distance is very far. But still my weighted, my KNN is going to give me this output as 1. But the impact on this neighbor is more than these 7. Okay, so one need to avoid this kind of confusion. We go for what? We go for what? Weighted KNN. We go for weighted KNN. Okay, now impact on the nearest neighbor on the query should be more than the farther away points. Then the farther away points. Okay, see here. So for example, if I'm going to give this one, okay, these are 2 here, these are 2 here. If I'm going to give for this which the black, okay, this random point belongs to this one means it will choose green. It will choose green if I apply k as 5 and it will choose green if I apply KNN. Now let's apply weighted KNN and see what is the methodology. Okay, weighted methodology. Now students, after calculating, okay, the first step is to reach to the points. The first step is till the distance we have calculated. The concept of till the distance remains the same. And the ranking till here it's the same. Given the set of points, you calculate, you use the Euclidean distance. Okay, you use the Euclidean distance. Okay, and you take the square root and you have ranked. And you have ranked. Till here it is the same in weighted KNN. Okay, till here it is the same. The first half is the same till here till you rank them. Okay, after ranking them students, after ranking them, say for example I have taken k as 5. I have taken k as 5, so I will take the majority of the k, right? So this is the distance I have calculated, right? This is the distance I have calculated. Till here you people know to calculate the distance, and till here we have ranked the first 5 neighbors. Okay, the concept of the KNN is applied here. Okay, and from after this only the weighted KNN differs. Now you calculate the weight. Then based on the weighted function, distance increases, the weight decreases, and then the simplest weighted KNN function. So how it goes is, so till n you know, this first step is to take the inverse of the distance. Take the inverse of the distance, inverse distance, that is inverse. So this is the distance, right? So the formula is 1 by d of I, that is 1 divided by 0.2. Till here it's the same. Till here you do the same process. Yes, till here you do the same process, the square root, right? Here you get it. Okay, then you calculate the KNN value, right? So these 3 are taken, right? If the k is 3, these 3 are taken, chosen. So for these 3, what is the distance? 4, 3 and 3.65. Till here you know. Okay, so till here you will be doing the same concept. Till here you will be doing the same concept and you get these values, because since it is k as 5, I am putting k as 5. So I have solved some other problem. Okay, and I have got some 5 distance value. Okay, now what am I going to do? Calculate the weighted inverse. Calculate the weighted inverse. So 1 divided by d of I. So 1 divided by 0.2. Okay, 1 divided by 0.2. Then 1 divided by 0.5. Then 1 divided by 0.7. Then 1 divided by 1.2. Then 1 divided by 1.5. You get, what is the value? 1 divided by 0.2. What value you get, students? 5. 1 divided by 0.5, what value you get? 2. 1 divided by 0.7, you get 1.4. Then 1 divided by 1.2, you get 0.8. Then 1 divided by 1.5, I get 0.6. That's the first step you will be doing. That is, still here you know how to do. Then the further procedures for weighted KNS, you will be calculating the weights. Okay, after calculating the weights, students, you will be summing up the weights, aggregating the weights. Okay, I equal to 1 to n, summation of. So 5 plus 2 plus 1.4 plus 0.8 plus 0.6, it gives you 9.8. It gives you 9.8. That will be the second step. Okay, the third step is To calculate the weight, Wi divided by sum. Wi divided by sum. That is 5 divided by 9.8. That is 5 divided by 9.8. Then 2 divided by 9.8. Then 1.4 divided by 9.8. Then 0.8 divided by 9.8. Then 0.6 divided by 9.8, which I have written here. The values I have got. 5 divided by 9.8 is 0.5. 2 divided by 9.8 0.2. 3 divided by 9.8 is 1.4. 0.8 divided by 9.8 0.08. And 0.6 divided by 9.8 0.06. Now I have calculated. Okay. Now I have calculated the values. Now add the weights of the same class. Add the weights of the same class. That is, in this case, 2 are red and 3 are green. 2 are red and 3 are green. So I am adding this weights, these two weights, what I have got, and I am adding these three weights. I'm adding these three weights. So when I'm adding these two weights, what is the value? So 0.5 plus 0.2. Can you see 0.5 plus 0.2? Because these two belongs to the same class red. You see, these two belongs to the same class red. Okay. Now, zero point 0.4 plus 0.08 plus 0.06. 0.4 plus 0.08 plus 0. Belongs to 0. Okay. Now, which has the weightage? 0.714 has the weightage and 0.28 has the weightage. Which has the maximum weightage? Whether the red class has the weightage or the green class has the weightage. Whether the red class or a green class, which has the more weightage? Hello?
Hello?
Which has the
Yes,
more
class.
weightage? Yes, students?
Red
Which has the
class.
more weightage? Red class, exactly. So the red will be chosen as the neighbor. Okay, the red will be chosen. So given a particular instance, whatever we have been calculating, so it belongs to red class. It belongs to red class. But if I could have used KNN, I could have stopped here. I could have stopped here and green could have been chosen. And green could have been chosen. Okay, if I could have applied KNN, green could have been chosen. Since I have applied weighted KNN, that is, what did I tell you? What is the impact of the nearest neighbor on the query should be more than the farther away points. Can you see? The impact of the nearest query should be more. The impact of the nearest query is more than the farther away points. And here's the farther away points. So these green dots and this the number of dots are okay, fine. But these two red dots are very closest to this particular neighbor. So the red is chosen as the neighbor. So this dot will be classified as red. It belongs to the class red. Is it clear, students? Is it clear whatever I'm telling you? Hello? Is it clear whatever I'm telling you? Hello? Understood?
Yes, sir.
Yes, sir.
Understood, students?
Yes, sir.
Yes, sir.
Yes, sir.
Students, the last topic is VC dimension. Vapnik Chernovskis dimension. Okay, so otherwise called as VC dimension. Okay, in machine learning, we call this as VC dimension. Okay, students. Okay, see here, I think so. Should be very a cakewalk for you since you have known all the types of classification and everything. This comes under module 2. This comes under module 2. Okay, module 2. Okay, so I have put it in module 3. I mean, to add these slides, I put it in module 3. Okay, since I'm teaching, I thought I'll add it in module 3 itself. Okay, but according to the syllabus, it is in module 2. Okay, students, no problem. Okay, now students, binary classification problem. I want to classify whether it is a cat or a dog for two data points. For two data points. For two data points. Okay, for two data points, I want to classify whether, okay, which class I might belong to for two data points. What are all the different possibilities, students, I can classify? That is, case one, I can classify both the data points as cat. Yes. Case two, I can classify one as cat and another one as dog, those two data points. Case 3, I can classify one data point as a dog and another data point as cat. Case 4, I can classify both the data points as dog. Isn't it, students? For two data points, given a two data points, whether if I want to classify whether it belongs to the category of cat or a dog, so I can classify, okay, one as both the data points as cat, one as cat, one as dog, okay, that is one as dog or one as cat or two as a dog. Okay. Now the same concept if I apply for two data points, it can be classified in four ways, right? Positive and negative. If I want to classify it in a positive and negative way for two data points. So both can be positive, one can be positive, one can be negative, or one can be negative, one can be positive, or both can be negative. That is for two data points. Okay. But if I want to classify three data points, if I want to classify three data points, what are the different possible ways I can classify, students? Okay, I can classify all three are positive, two are positive, one is negative, or two are positive, one is negative in this way, one is positive, two are negative, two are negative, or one is negative, two are positive in this way, two is negative, one is positive in this way, two is negative, one is positive in this way, and all are negatives. Okay, that is for three data points in eight ways. Now you tell me, for two data points it is four ways, for three data points it is eight ways, then for n data points how many ways? N data points how many ways, students? Hello, hello. For
Power
n
and
data points how many ways?
2 power n.
Very good, excellent, students. Substitute the value of n, you get right. So two data points, four ways, four ways. Three data points, 2 power 3, 8 ways. Yes, 8 ways. That is for n data points, it can be classified into 2 power n ways. Okay, students. Now students, now if I want to put a scatter plot, okay, scatter plot, okay, shattering. Okay, it's not scatter, it's shattering. Okay, shatter. It's shatter, not scatter, it's shatter. Okay, shatter plot with 2 points classifying in a straight line. Okay, I will use it something unique color, gold color. I will use it. Okay, okay. In all four cases, is it possible to draw a line that separate positive and negative data points? Okay, yes. Now, students, kindly please understand. Now, what I'm trying to say is, I'll get back to this point. Okay, first let us see this diagram, then I'll get back to it. Can I classify this two data points? Okay, with the help of a straight line and say that is one. These are on top of this line is positive and the another one is negative. Yes. Yes, can you see one data point positive, one data point negative? Yes. So one data point positive, one data point negative. Okay, then two data points negative. I'm able to classify, and above this might be positive. So a line can shatter 2 points in a two-dimensional space. In a two-dimensional space, that is x1 and y, x-axis and y-axis, in a two-dimensional space. Okay, I will come back to the definition. Now, what about three data points? What about three data points? Can it shatter? Okay, can it classify the data points? Yes, it can classify by drawing a straight line, positive, negative. Yes, it is able to classify. Here I can classify positive, negative. Here I cannot classify. I cannot draw a line like this, or I cannot draw a line like this, or I cannot draw a line like this. This cannot be classified. Here I can classify. Here I can classify. Here I can classify. Here again I cannot classify. Here I can classify by a straight line. Here I cannot classify. Here I cannot, sorry, here I can classify. Here I cannot, here also I can classify. So these are the two data points which I cannot classify. Now, the definition of shattering is, okay, a set of example is shattered by a set of functions hypothesis H for every partition of example for all the examples. If I am able to shatter all the data points, if I am able to shatter all the data points, okay, let it, I'll come back to it. Okay, I'll come back to this particular definition. I don't want to confuse you by the definition. Now, let us see, this is for this particular data point, students. Now, for three data points, okay, I am not able to shatter these two data points. Okay, I am not able to shatter these two data points, but other points I am able to draw a classification line. Okay, but for these data points, now let us take some other data points for three data points. Okay, some other way of plotting, some other way I'm going to plot for three data points. Okay, another set of three data points. A line can shatter three data points in two dimensions. Now can I shatter? Can I classify positive and negative? Yes, I can shatter. Here I can shatter positive and negative. I can draw a straight line. Here I can positive, negative. I can shatter. Here I can classify positive and negative. Okay, here I can shatter positive and negative. 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 That is, for this data set, okay, given three data points, I am able to shatter all the points. These are the 8 ways I can write. 2 power n is 8. 2 power n. That is 2 power 3. Is 8. Now I am able to classify for this points, but for this points I'm not able to classify. But still, if my data set changes from this to this, from data set changes from this point like this to this, okay, I am able to shatter. Here I'm not able to shatter, okay, for these data points, but here I'm able to shatter for the other. Here for three dimension, for three data points, not three dimension, for three data points. That is, students, that is, if let it be three data points, let it be three data points, okay, three data points. If I can apply the data points on any particular random plotting, either this or this, in this I was not able to, but in this I was able to, something like this, if my data set was like this, but in this kind of a plotting I was not able to plot. Okay, but in this kind of a plotting I was able to plot for all 8 ways, but here only 6 ways I was able to plot, but but for three data points, if there exists any one way, any one way, okay, either this or this, like any one way, then I can say that my shattering is successful on those three data points. Any one way is enough. It's fine. Okay, if I'm able to partition every partition of examples into positive and negative example, there is a function here that gives exactly these labels. That is, if I am able to shatter my data points in all 2 power n ways, that is 2 power, in this case it is 2 power 3, which is 8, ways, all my hypothesis I'm able to classify, then it is my VC dimension. For this is, say, for example, for 3, maximum is 3. Okay, now let us see. Okay, it may not be able to shatter every set of possible 3 points in 2 dimension. Can you see? It may not be able to satisfy every dimension. Okay, 2 points, 3 points in 2 dimension, but it is enough to find one set of 3 points that can be shattered. Okay, I have found one set of points which can be shattered in all the 8 ways, in all the 8 ways. Okay, but it is not possible for me to shatter in all the different possible way. But if I find one particular point which can solve in 8 ways, it's enough for me. Okay. Okay. Now let's consider a set of 4 data points. Now you come up with any combination. Okay, in this particular diagram, I cannot shatter. I cannot classify this. Okay, this I can classify. I cannot classify this. I cannot classify this. I cannot classify this. I cannot classify. Few examples. I cannot classify if I want to draw. Okay, like that you come up with any possible combination. Okay, of red and thing. Okay, you cannot find a data point in any group. Like, can you see? If I change my data points from this to this, I'm able to find for 3. Okay, but if you change my data set, let it be any combination, cannot find a single set of 4 points that can be shattered. That is in all the 16 ways. It should shatter all the 16 ways. I cannot find. So the maximum VC dimension, okay, the VC dimension of a straight line in 2 dimension is 3. Maximum it is 3. Till 3 data points only it can classify. 3 data points only it can classify. The maximum number of points in 2 dimension, R squared is 2. It is 2 dimension. It can be shattered by a straight line is 3. VC dimension of a straight line in 2 dimension is 3. The maximum number of points that can be shattered by a H is called as VC dimension of H. Hypothesis. H means hypothesis. VC dimension is one measure that can characterize an expressive power of the capacity of a hypothesis class. Are you people able to understand? Here, put your hands down. Whenever I am asking you, you should put your hands down. Please put your hands down. Kindly please don't
Excuse
raise
me,
your
sir.
hands. Yes.
Could you please
Yes,
explain why
please.
the maximum number of points is 3, not 4? I mean, what's the problem with 4 points? I'm not able to
Exactly.
uh,
Kindly please
get it.
concentrate. Kindly please concentrate. Kindly please concentrate. Here, can you see? I am keeping my data points. I am plotting like this in this particular way. Can you see the way of plotting? Way of plotting. Can you see the way of plotting? Hello?
Yes, sir.
Hello? Can you see the way of plotting? Yes. Okay. Now I am coming up with all the classification of positive and negative for 3 data points. 3 data points. Yes. 3 data points. As I told you, one dog, one cat, two dogs, 2 cats, 3 dog, like that, right? So the maximum to classify positive and negative classes is, how can I classify? I can classify all as positive, all as negative, 2 positive. The probability. Yes, I have plotted. Yes or no? Yes. Yes or no, man?
Yes, sir.
Can you
Yes.
understand this diagram? Okay, yes, you have understood this diagram. Now, if I draw a slate line to classify positive and negative, if I want to classify positive and negative, here I am able to classify, 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 here I am not able to classify, here I am able to classify, here I am able to classify. But these two I am not able to classify. Yes? Yes or no?
Yes.
Okay. Since I am not able to classify these two, now I am trying to change my three data points and I'm trying to plot it in a different way, not in the same way. You're getting the point? Now I'm trying to plot it in a different way. What is a different way? From this particular angle, I have changed it to some other data point. My data points can be in anywhere, right? In a 2D space. Yes or no? Yes
Yes,
or
sir.
no, man? Now my plotting is something like this in this particular variety of way. Now I'm just changing my dots. I'm just changing my dots. All 3 are green. All 3 are red. Okay, all 3 are red. Okay, all 3 with the same impossible ways. So these are the different things. Now if I'm able to plot it, I am able to successfully find, okay, in every possible 8 ways, I'm able to plot. I'm able to plot. I'm able to, I'm able to plot. Yes or no? I'm able to classify. Yes or no, man?
Yes, sir.
For this particular data set, if I plot like this, I was not able to. For 3 points only. For 3 data points. But for the same 3 data points, if I am able to plot it in this way, I'm able to get it. Yes or no? I'm able to classify it. Yes or no? So if there exists a single plotting, if there exists a single plotting out of n dimensional ways, I can plot the three plots into n number of ways, right? In any way, right? Yes or no? Yes or no? In any way I can plot. Yes or no, man? One way of
Yes.
plotting is this. One way of plotting is this. If there exists a single way which can scatter, which can classify all the 8 data points, all the 8 possible ways, then it is said to be the BC dimension. I can apply it in my BC dimension. Okay. But now if you take for 4D, four as a four data points, you plot it in any way. Let it be, this is one way. You can plot it in any way, like this, right? You can plot it in like this way also. For 4 data points, you can plot it in this way also. You plot it in any way and take out all the 16 combinations in this particular way, just like this. You take out like this one, you put another one, and you will get 16 combinations. Okay. Or you put a graph like this, or you plot it in 16 combinations. Or you put a graph like this, like you plot it in 16 combinations. Okay, you will plot you put a graph like this and plot it in 16 combinations of 4. You will never get in all the 16 ways. You can never classify like this all the possible ways. Are you getting the point? Are you getting the point? Hello?
Yes,
Are you
sir.
getting
Yes,
the
sir.
point? You know, you are able to understand what I'm trying to say?
Thank you.
Understood, pa? Understood what I'm trying to say.
Yes,
So
sir. Understood.
the maximum number of points for a straight line, if you want to draw a straight line, is 3. The VC dimension is maximal till 3 data points only you can do. If you go beyond 3, you cannot. Okay. Now let us change this straight line into a triangle, rectangle, rectangle. Assuming that inside the rectangle it is a positive class, and outside the rectangle it's a negative class. From a straight line, now I'm moving on to rectangle. Now this is for 2 data points. For 2 data points, I'm able to classify. Inside it is positive, outside is negative. Yes, I'm able to classify. Inside it is positive, outside is negative. Yes, I'm able to classify. Inside negative, outside inside positive, outside negative. Inside positive, outside negative. Yes, I'm able to classify. Okay, done. This is for 2 data points. Axis aligned rectangle. What about 3 data points? What about 3 data points? Yes, I can do it. 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 That is for 3 data points in 2 dimensional space. I can do it. I'm able to classify. Now, for 4 points, for 4 points, okay, using an array. Yes, I'm able to classify with the help of a rectangle. I'm able to classify. 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 So the VC dimension, the maximum number of points in a 2 dimensional hyperplane that can be scattered by a rectangle is 4. But for a straight line is 3, but for a rectangle is 4. So the VC dimension of a rectangle is 4. Axis aligned rectangle cannot be scattered for 5 dimension. When I apply, like how I applied straight line on a on a 4 data points, I was not able to classify. You take any points and try. You will never be able to classify. The same way, but when I change from rectangle, I was able to classify till 4. But when I go for the 5th point, I will never be able to classify. I will never be able to classify for 5 dimension. Okay. You're able to get it, students? Hello? You're able to get it? Understood?
Yes, sir.
Now you are able to understand whatever I'm telling you. Hello? You're able to
Yes.
understand? Any doubts?
Yes, sir.
Yes, sir. One doubt, sir.
Yes, pa, please.
Sir, what is
Please.
the significance of this VC dimension? I mean, where can we apply this?
See, pa, here when you have the number of points, that's what I'm trying to tell you here. The number of points when you are going to increase. That's what the point is here for 3 dimension, for 3 data points, not for 3 dimension. Kindly please excuse, it's a slip of tongue. For 3 data points, Okay, for 3 data points, I am able to successfully classify in any possible way of with respect of positive and negative class.
Yes, sir.
Okay, I'm able to classify. You come up with any set of data points. This I am showing you one pattern. Here I'm showing you one pattern. And let it be any number of pattern. If there exists one pattern also, you can able to classify positive and negative classes. You can apply in decision trees. Okay, people are using in multiple applications. Okay, people are trying to use the VC dimension in decision trees and trying to predict the classification label. People are trying to use it in multiple ways. One of the ways I can think of is decision trees. People are working on decision trees.
Yes, sir.
Okay.
Got it,
Uh,
sir.
okay, people are working on multiple classifiers where they want to apply this kind of VC dimension and trying to classify with the points.
Yes, sir.
Okay, people are working on navy base. Okay, people are working on KNN, trying to fix up a VC dimension on KNN also. People are trying to put up in weighted KNN also and trying to classify. People are working in a perceptron also and trying to bring in this concept, but lots of work is still going on. Okay. Okay, very good, excellent. Any other doubt, students? Any other doubt?
No,
Any other
sir.
doubt, students? Okay,